the goal of this video is to help you make sense of rational exponents. Okay, and what rational exponents is, that's just a fancy way of saying exponents that are fractions. Sometimes we call these fractional exponents. Okay, but the more proper term is rational exponents, right? All that is exponents that are fractions, right? And we're going to help you to make sense of that idea. For this video, you really should have a calculator with you. So if you need to, please pause the video, grab a calculator, right? A simple calculator, or you can use a calculator on your cell phone is fine. So please pause and grab a calculator if you need one. All right, before we actually use some exponents that are fractions, I want to just do a little quick review on some ideas, right? So first, we've been talking a lot about how multiplication represents repeated addition, and exponents represent repeated multiplication, right? So for example, if I were to illustrate what 3 times 5 means, right, I could say this represents 3 groups of 5. Right? Or I could write that out as 5 plus 5 plus 5, right? 15, right? So multiplication is just repeated addition, right? 3 groups of 5 that are added together, okay? That's multiplication. Exponents, that's repeated multiplication, right? So 5 to the third, right? We can think of this as saying 3 5s that are being multiplied together, right? 5 times 5 times 5. So that's 125. Okay? So again, key idea, exponents, you've got multiplication that's being repeated. Multiplication is addition that gets repeated. All right, can you just take a second here, pause, and can you write out what 4 times 7 means and what 7 to the 4th power is, right? And if you need a calculator to do the 7 to the 4th, you can. Right? So please pause and do that. Right? So I really want to hammer this idea in your brain. Okay? So 4 times 7, right? That just means we have 4 groups of 7, right? Or 7 plus 7 plus 7 plus 7, right? So 4 7s that are added together, that should just be 28. Versus 7 to the 4th, right? The multiplication is getting repeated. So that's saying 7 times 7 times 7 times 7. 4 7s that are multiplied there, right? You can use a calculator on that, and I think you get 2401, 2401. All right, so now we're going to apply the same idea to thinking about fractions, right? So I'm going to look at 3.5 times 16, and 16 to the 3.5 power, okay? So again, let's remember, multiplication here means repeated addition. So what we want here is 3.5 groups of 16. So that would be, here's one group of 16, plus a second group of 16, plus a third group of 16, and then I need to add half of 16. Right? What's half of 16? Well, that would be 8. Right? And that makes sense because 8 plus 8 is 16. Okay? So it's 3 groups of 16 and then half of 16. Okay? If you add all that up, that is 56. Okay? All right, so now let's think about 16 to the 3.5 power. Okay? So remember, exponent tells us that we're multiplying, right? And we're telling us that we're going to have 3.5 16s that are being multiplied. So what would that be? Well, that would be 16 times 16 times 16. There's 3 16s right there that are being multiplied. And then I need half of a 16. Okay? But it's not 8. It's half of 16 in a multiplication sense. Right? Half of 16 is actually 4. Right? Think about that for a second. Right? Let me kind of compare these for a second. Right? Go back over here. Why is half of 16 when you have multiplication 8? Well, it's because 8 plus 8 adds up to 16. Right? 8 is half of 16 in an addition sense because it adds up halfway to 16. Why is 4 half of 16 in a multiplicative sense? Well, it's because 4 times 4 is 16. Right? This is half of 16 in a multiplication kind of way. 4 times 4 gets me back to 16. right? So 16 to the 3.5 power, that means we've got 3 16s that are being multiplied, and then we have half of a 16 that gets multiplied. 16 times 16 times 16 times 4. You can use a calculator on that, but that comes out to be 16,384. All right, kind of a weird idea. Let's kind of look at another one here. So I want to just really emphasize this idea of halves. So 1/2 times 100 versus 100 to the 1/2 power, right? So half of 100, when I think about it here, 1/2 times 100, that's obviously 50, right? Why? Right? Because 50 plus 50 adds up to 100, right? Remember, multiplication tells me something about addition, right? So it makes sense that half of 100 is 50 because 50 plus 50 adds up to 100. What's 100 to the 1/2 power? Well, that would be 10. Why is it 10? Because 10 times 10 is equal to 100, right? Remember, exponents tell me something about multiplication. So 100 to the 1/2 being 10 makes sense because 10 times 10, right, gets me back to 100. This is like half of the way. Half of the way, and then another half of the way gets me the whole way there to 100. All right, I'm going to do one more example, and then the last ones you're going to do on your own. Okay, so let's think about this. 4.5 times 36 versus 36 to the 4.5 power. Okay, so remember, this multiplication here tells me something about addition. So I need to have 4.5 36s. Okay, so here would be 4 36s. 1, 2, 3, 4. Right, and then I need a half of a 36. Right, well, half of 36 in an addition sort of way would be 18. Right, that makes sense because 18 plus 18 adds up to be 36. Right, so 4.5 groups of 36 is 36 plus 36 plus 36 plus 36 plus half 36, which is 18. And that adds up, I believe, to be 162. Okay? All right, so let's do the multiplication one. Or I should say the exponent, right? This exponent here tells me something about the multiplication. So I need to have 4.5 36s that are being multiplied. So that would be 36 times 36 times 36 times 36. Right? So there's 4 36s that are being multiplied. And then I need half of a 36. Right? What would half of 36 be in terms of a multiplicative sense? Well, it would be 6. Right? Because 6 times 6 gets me back to 36. All right? So 36 to the 4.5 power is 4 36s that are multiplied, and then this half of a 36. Right? Half in terms of multiplication. Okay? All right, and when you multiply this all together, this is why you need a calculator. This comes out to be 10,077,696. All right, these last two I would like you to try on your own. 5.5 times 9, and then figure out what 9 raised to the 5.5 power is. Right? Please try those on your own, and we'll talk about them in class.